Hey, what's up everybody? This is Easy Speeds and Feeds. Today I'll show you guys how to mill some ductile cast iron. So let's get started. Alright, here's our part. Pretty interesting looking. And it needs to be milled. And we're going to pretend like it's ductile cast iron. So, there's a couple things we need to do first before we can start milling it. And that is to create some extra levels with wireframe and then create a new plane, so it just makes it a lot easier to start milling. So we'll go to levels, type in 2, hit tab, go down to name and type in wireframe. It's our first step in creating a wireframe level. We'll name level 1 solid. We'll select our part, go to wireframe, and click on curve all edges. Hit the check mark. And that gives us a bunch of wireframe on all the edges of the solid. Next, we click on select all wireframe, go to change level, deselect use active level, and type in 2. That should put it on our wireframe level, and it is. So that's looking good. So far, so good. Next, we're going to draw some wireframe to find the middle of the part. Okay, and we'll create a point right in the middle of the part. That looks good. We're doing that so we can create a work coordinate system that is in the middle of the part. This is just the way I like to do it. Right now I'm just measuring and making sure that point is in the middle. And it is. So we can go to planes, duplicate the top plane, name that 100 or op1 or something along those lines. Edit the work coordinate system, click on the ball, then click on that point we drew, and that puts our work coordinate system right in the middle. So we'll delete those lines we don't need. So we got our wireframe, our work coordinate system ready. That's looking good. Next, we are going to draw our stock. We're going to anchor to the center. And next, we'll type in our width and our height. So we'll just click somewhere on the page, go to width, type in 4, height 1.75. And we drew our stock because we're going to do something called dynamic milling. And dynamic milling is easiest when you have your stock drawn and wireframe to work with. That's the easiest way to set up dynamic milling. So we created another level. We'll move the stock to that next level. Type in 3. There we go. We got 3 levels, a solid, a wireframe, and a stock. It's looking good. So we're pretty much set up to start milling. So we go to Machine, Default, and now we will start milling this part. click on Dynamic Mill. Machining Regions, click on the Stock. Avoidance Regions, let's click on the Part. Click on all the edges. And this tells the dynamic toolpath not to go into the part. It's looking good. Hit the check mark. Click on From Outside. There we go. Go to Tool. Select Library Tool. And click None. Click on End Mills. Click the check mark. Let's find a 1/2 inch end mill. And feel free to pause the video and rewind it and do whatever you got to do because we are going pretty quick here. So we make that tool 1. We go to easyspeedsandfeeds.com. We go to ductile under cast iron. We find our speeds and feeds. Go 200 surface feet, 1/2 inch diameter, number of teeth. It's a 6 fluter, feed per tooth, 2 thou. So we found our inches per rev and our RPM, so we just type those in. 12 thou inches per rev, 1,528 RPM. That gives us a feed rate in inches per minute of 18. Okay. So the best speeds and feeds to use is always from your tool manufacturers. But if you can't figure that out and you can't find their speeds and feeds, easyspeedsandfeeds.com is a great place to get you started. Okay, so we type that in. We go to cut parameters. We're going to change stock to leave on walls to 0 and the floors to 0. Step over. We'll change to 25 thou. Keep it light cuts. Okay, that all looks good. Linking parameters. We'll click on the bottom of the wireframe. Turn everything to absolute. Our back feed rate will change to 400. So when it starts going in tricutal motions, it will go 400 when it's not in contact with the part. So we will run the back plot, and it's looking good. 25 thou cuts, 18 inches a minute, 1,528 RPM. And as it retracts, that will be going 400 inches a minute. So you're cutting at 18 inches per minute, and then when it retracts to go back around, because it needs to be climb cutting, so right there, 18 inches a minute, and then when it retracts around, it's 400 inches a minute. So that saves a lot of time. And that's that back feed rate you can adjust. So we're going to analyze the distance in these little slots. And after we analyze it, we're going to figure out what tool to put in there. So our 1/2 inch end mill would not fit, so we're going to have to switch to a smaller end mill and try to machine those regions by themselves since everything else is machined. So we will give dynamic mill a shot, click on machining regions, Okay, hit the check mark. We'll click on Stay Inside. Okay, we go to Tool. So that 1/2 inch end mill is too big. We have to switch tools. Go to Filter, have end mill selected, and let's select a 1/4 inch end mill because the slot was around 380 thou. So 1/4 inch end mill should work pretty good. Go back to easyspeedsandfeeds.com to find a good starting point. It's a 1/4 incher, 6 fluter. We'll adjust our feed per tooth and diameter. Also adjust the inches per rev and the RPM. And you get 3056 RPM and 18 inches a minute. So we type that in. That all looks good. We're just double checking right there. Cut parameters. Step over 12 thou. Now let's examine what we did. So that looks not right. It's not going down a 1/4 inch. It's starting too far above. So we have to go back into parameters, adjust some things, and hopefully we can get it to machine right. So we're back in parameters, go to linking parameters, our depth, click right there, that'll be a 1/4 inch, regen that up, we'll backplot it, and so that looks pretty good. It's using like a ramping motion to do all the machining, which will work. But it is leaving some area unmachined. So we have to address that before we move on. What we can do is extend the wireframe and then rechain this slot. So we extend the wireframe on that side of the slot. We extend the wireframe on this side of the slot. Hit the check mark. Go back into geometry. Deselect that. And rechain it. Okay, backplot. That's looking a lot better. Now this is just one way to deal with a slot like this. There's lots of ways to do it. But that's why I like working with wireframe and creating wireframe from the solid, is that you can just create lines that help you get things done. Okay, so we're going to try the same thing on the other side. Create some more lines. We'll copy and paste this toolpath because we like everything about it except the chain. So we deleted the chain in the new toolpath. Now we're rechaining it on the other slot. Hit the check mark. Just like that, we got the other slot done. So things are going good. Got most of the part done. I would periodically save while you're doing all this. It can add up to a lot of work. Next, we want to add some stock. We'll click the center and we will type in the stock manually. So we will just measure the Y, that's 1.75. Go into stock. Go from the center, Y 1.75, X 4, the Z 0.25, click the check mark. Now we can go into verify, see what we got. So that looks correct. Go to Tool Components, turn off the holder, and click Play. So it's doing its dynamic mill, taking 50 thou cuts with that 1/2 inch end mill, avoiding the smaller slots because it can't get in there. Doing this big slot in a tricotal motion, feeding at 18 inches a minute while cutting, and then coming back around 400 inches a minute. That's that back feed rate that we adjusted. So there's our 1/4 inch end mill doing a ramp dynamic mill on both those slots. That's looking good. And one more thing we want to add is a finish pass, because dynamic milling doesn't really give the best finish. It gives kind of a choppy finish, something you can definitely notice. So we're just going to chain the whole thing, and we're going to do a finish pass with a 1/4 inch end mill so we can get into all the slots. So we go piece by piece, make sure we chain the whole thing. That's looking good. Hit the check mark, go to Tool, select the 1/4 incher, put in our speeds and feeds from easyspeedsandfeeds.com, 3056 RPM, 18 inches a minute. Cut parameters, depth, minus 0.25, multi-pass passes, we can do 2. So we go into the parameters of our other toolpaths, go into the cut parameters, leave stock on walls, we'll leave about 10 thou per wall. So our finish pass takes out 10 thou. And again, dynamic milling leaves a rough, choppy finish. That's why we're adding all the finish passes. So we go into verify, click the play button, we can speed things up because all we want to see is make sure that it's having that finish pass. If we zoom up, it looks like it's definitely leaving about 10 thou per wall, which is good. There's that dynamic mill using a ramp method for those slots, leaving 10 thou per wall. There's our finish pass right there. Give it a nice clean finish. So there we go. There's our ductile cast iron part, all milled out. As you can see, we didn't do much contouring because the metal is so hard you really don't want to load your tool up. So dynamic milling is a great way to go at a part like this. I hope you guys liked it, and be on the lookout for more videos. Thanks.